All right, this lesson is going to take up the last 3 examples on mean value theorem, and we're going to see this is what it's going to look like in Delta Math for this particular assignment. So there's 3 basic answers that you're going to come up with. Either it's going to be true, it's going to be false, or it's going to be you can't tell if it's really true or false. And this is the way that Delta Math is phrasing the question. So it's a little bit, it's same concepts as we were doing in class, but there's a couple things you have to check, okay? So selected values of the function are shown in the table below. The function f is continuous on a closed interval and differentiable on the open interval. So if it's continuous and differentiable, that means that MVT, the mean value theorem, definitely applies, okay? So we're supposed to determine the validity of the statement. So if the mean value theorem applies, that means that it guarantees that at some point the derivative has to equal that value of the slope. Well, what I have to check is looking at this data to see if this slope appears anywhere, okay, in these data points. So I actually have to check 3 things. I have to check between here and here. So if I did that slope, so this is from on the interval from -1 to 0, okay? So the slope equals -9 minus -8 over 0 minus -1. So that's going to be -1 over 1, which is -1. Didn't equal 13/3 anywhere, okay? Then I'm going to look at this interval right here. So that's the interval from 0 to 1. So my slope is my y values, -6 minus -9 over 1 minus 0. Double negative goes positive. So we've got 3 over 1 or just 3. Doesn't equal 13/3. There's another set that we can look at. It's this one here, the first point to the last point, looking at the slope there. So I'm going to put in, from -1 to 1. So my slope there with my y values would be -6 minus -8 over 1 minus -1. All the double negatives go positive. So we've got 2 over 2, which equals 1. At no time did it equal 13/3. Sorry, fix this. And it doesn't want to charge. Let's go that direction. Fell out on here. That's the problem. Okay. So at no time does it equal 13/3. So we really can't tell if it is really true or false. So this one could be either true or false because we don't have enough evidence. Because there could be other slopes in here in between those, some decimal points that could maybe work, but we can't tell from the data that we have. All right, on 13, we're going to make a change. So you can see one. So we're going to change this 3 to a 2 and that 18 to a 17. Okay. So again, same problem. It says it's continuous. It says it's differentiable. So we know the mean value theorem applies. So that means that somewhere this slope, the derivative should equal this slope somewhere. So I'm going to start testing those slopes. Okay, as long as I find one, I know I'm good and that it's true. So I'm going to look at this interval here first. So from 0 to 2 slope. So I'm going to do my y value. 17 minus 3 over 2 minus 0. 17 minus 3 is 14 over 2, which is 7. So that definitely worked. We actually fixed it, found it in that first try. So that one actually works, and this one would be true. All right, last one here. So this one, again, we're going to do the same thing. There's a little bit of a catch in this one. We see continuous, but it says there's also does not exist a value of c such that the slope equals 7. Determine the validity of the following statement. The function is differentiable. Well, in order for the mean value theorem to apply, I have to be continuous, differentiable, and my slope, they're saying, doesn't equal 7 somewhere. So let's see what happens. So let's start doing some calculations here. If I look at the interval from 0 to 1 for my slope, I've got -5 minus -1 over 1 minus 0. So I've got -4 over 1 or -4. So far, that's a true statement. I'm going to look from 1 to 4. So my y values are -29 minus -5 over 4 minus 1. So it's looking like -21 over 3, which is -7. So still a true statement there. But then I have to also check those endpoints. So I'm going to go the interval 0 to 4. So I've got -29 minus -1 over 4 minus 0. Double negative is going to go positive, so I've got -28 over 4. Something's wrong. There must be a typo in this one. There's a typo. This was supposed to be a -7. So actually, I had it in this one here, right? But either one of those would have proven that this is a false statement because we actually got the derivative equal to -7, and it said it did not exist. So this one is a false thing because the function is differentiable with a slope equal to 7.